topic for today's 50th module is physical significance of general solution of transmission line. Before diving into the topic, let's see some basic terminologies. Starting with transmission line, a device which is used for transmitting or guiding energy or signals from one point to another is called transmission line. In case of transmission line, parameters such as resistance, inductance, and capacitance cannot be separated physically. These parameters are distributed along the transmission line and are called as distributed line parameters. Distributed line parameters are further classified as primary constants and secondary constants. In primary constants, we have resistance, inductance, capacitance, and conductance. Let us see their details. A resistance R is defined as the loop resistance per unit length and has unit ohm per kilometer. Inductance is defined as loop inductance per unit length and is the sum of inductance of both lines. Capacitance is defined as shunt capacitance between two conductors per unit length and is measured in farad per kilometer. Conductance is defined as shunt conductance between two conductors per unit length and its unit is mhos per kilometer. In secondary constants, we have characteristic impedance, propagation constant, attenuation constant, and phase constant. In characteristic impedance, it is the impedance of transmission line when length of transmission line is infinity. It is purely a function of capacitance and inductance. Propagation constant shows the nature in which the waves are propagated along the line. Attenuation constant determines the reduction in voltage or current along the line and it's expressed in Napier per kilometer. Phase constant determines the variation in phase position of voltage and current along the line. The distortion during transmission of signals is mainly classified as frequency distortion and phase distortion. Frequency distortion: when a complex signal containing many frequencies is applied at the sending end, then at the receiving end, different frequencies are attenuated by different amount. Hence, the received waveform is not the same as that of the sending waveform and is known as frequency distortion. Phase distortion: all the frequencies applied at the input will not have the same time of transmission, with some delayed more than the others. Thus, applied signal at the input will be different from the received signal at the output. In the diagram below, we can see phase distortion. The general solution of transmission line. The general equation is a very useful form for the voltage and current at any point on a transmission line. From the general solution, we can get equations for voltage and current at any point on a line and the solutions to the wave equation. The two equations below show the general solution of transmission line. Physical significance of general equation. For a finite length of line, when terminated into characteristic impedance Z0, input impedance is Z0. So we can say when a finite length of line is terminated into characteristic impedance, it behaves like an infinite line. The equation Zn equal to Z0 defines the physical significance of general equation. Thank you.